Okay. Okay, hello everyone. So welcome on our 20th webinar running under the hood of Cloud Native and Kubernetes Warsaw. Today we are going to talk about the eBPF and Kubernetes, and our guest, who is Dawid Ziłkowski, will shed some light about what are the connectivity between, what are the connections between those two technologies, how we can use it, what we can do with that. Dawid works as a cloud native engineer for container solutions. So welcome, Dawid, on our webinar. It's very nice that you find some time and join us. We are very excited to host you. And yes, the webinar should take around 45 minutes, maybe a little longer, depends on how many questions you will have. So if you have any questions, just use a chat. We are also live on YouTube. And if you would like to be a speaker on another upcoming session, just drop us a message. You can find us on Meetup.org, CNCF platform, as well as on Twitter. So yeah, so I think this is everything in regards to announcements. Tomasz, if you'd like to add something, you are also the organizer, so feel free. If no, we can pass the stage to Dawid.
We can go.
Okay.
Yeah, I'm focusing on launching YouTube. There are some issues,
okay.
But no worries.
Okay, thank you, Dawid. So yeah, enjoy your time, and we are going on mute. So yeah, you can start. Thank you.
Yeah, thank you very much, Kuba. I'm very happy to be here. This talk particularly is also pretty interesting for myself, to be honest. I used to start with eBPF already 2 years ago, but back then it was also still pretty new technology. So I had to refresh my knowledge about it for that talk, and it was pretty great because so much stuff has happened in last couple of months in eBPF world. So yeah, I'm happy to share the knowledge with all of you. So yeah, let me share the screen and let's kick off. And now let's kick off. Okay, yeah, I believe you all see my screen. If not, then shout.
Yes,
Great.
Everything is fine.
So yeah, we'll be talking about eBPF in this talk and Kubernetes. These are two separate technologies. So let's start with that, right? eBPF is not something specific for Kubernetes. It's general technology in Linux kernel. So just to give you an understanding at the beginning. But yeah, I'll be talking about that in the details anyway. So, 2 words about me. Yeah, as you already heard, I'm Dawid Ziłkowski. I'm working for Container Solutions. We are cloud native consultancy company, basically. So yeah, we are helping companies with anything cloud native related, even no matter if it's like, I don't know, migration from bare metal to cloud, or if you're already in the cloud, but you want to improve your infrastructure. So yeah, we basically touch anything cloud native. And that's why, in order to be able to help these companies with anything cloud native related, then we need to be ourselves quite up to date with all the technologies, right? That's why that's part of the reason why I'm talking about eBPF now, because yeah, eBPF is something also new, something upcoming. So yeah, I had to myself just understand what it is, how it works, and if it's something that will be really important in the future, really interesting or not. So yeah, that talk will be about my findings about that. There is my Twitter handle and email. If you'll have any questions, of course, feel free to ask them during the talk or after the talk. But yeah, feel free to ping me on Twitter or on email if you'll have any additional questions later on. Okay, so as I said, we will be talking about eBPF and Kubernetes, and we have 2 main goals for this talk, right? First one is to understand the basics, the very basics of Kubernetes networking, especially how Kubernetes uses Iptables for networking. And the second goal is understand what eBPF is, and yeah, spoiler alert, is eBPF can replace Iptables. So that's why I'm talking about Iptables here already. Yeah, the goal of this talk is for you to understand why eBPF exists, what it tries to solve, and how it relates to current networking, current iptables-based networking in Kubernetes. So in order to do that, in order to explain you eBPF, what it's all about, we need to start with a little bit of history. We need to go back to 2013 when Docker was released, right? So when Docker was first released in 2013, then it's important to understand that Docker didn't invent containers, right? The containers did exist before Docker. What Docker did was only in brackets because it was a huge deal. But what Docker did is Docker made containers easy to use, because what the container is not what a container is just the process, Linux process, which is isolated with C groups and namespaces. C groups and namespaces, these are features of Linux kernel, which are in Linux kernel already for quite a long time, much longer than the Docker itself. Namespaces back to 2002. So from Linux kernel, actually, there's no such thing as a container, right? From Linux kernel perspective, it's just the process which is isolated from other processes. So so again, what Docker did is they made creating isolation with C groups and namespaces for processes really easy, right? Because before Docker, you could create container if you know how to apply C groups, if you know how to apply namespaces as isolation to a specific process, right? So just to have that clear. And in order to make everything as easy as Docker did for containers, they had to pick some. They had to make some decisions. They had to pick some technologies in order to provide you all that nice functionality. In order to make it as easy as Docker run Ubuntu SH or Docker push whatever image, wherever, in order to provide all of these functionalities that you have by Docker, they had to use some underlying possibilities, let's say, of features or Linux kernel or Linux program in general. As I mentioned, in order to create the container itself, they used namespaces and C groups, which are the features of Linux kernel. In order to provide networking for containers, however, they used iptables. They used iptables because at the very beginning, when the first release of Docker pops up, Docker itself, they advertised containers as tiny VMs. That may be a surprise for some of you. Something that nowadays we always say, don't treat containers as tiny VMs. It's different, right? But at the very beginning, that's how Docker itself saw containers. That's how they advertise containers. And that's the very reason why they picked iptables to provide networking for containers, because iptables work perfectly fine. They were already iptables is also super old technology. It's also for like 20 years in Linux kernel, I think, and it works perfectly fine for physical machines, for physical networks, and for VMs. So yeah, when Docker started getting tractions, when they released Docker, they just decided to use iptables because it just made sense, right? If they thought about container as a tiny VM, then it just made sense to use already existing iptables instead of just reinventing the wheel and creating something from scratch. Okay, so that's history lesson 1 about the Docker itself. I should actually mention that we are starting talking about Docker because Kubernetes at the end is a container orchestration platform. Right, it's just an orchestrator, so it uses containers. It uses containers as the base, let's say. It doesn't use Docker anymore in some cases, but that's another story. It doesn't matter for now. We have Docker covered, so let's talk about Kubernetes now. Kubernetes was first released just 1 year after Docker, 2014. And yeah, as you all know, I guess, it used Docker as a container runtime. Of course, it made sense, right? And because because Kubernetes used Docker, well, it still uses in some cases. That's why it also uses Iptables, right? Because yeah, Docker decided to use Iptables for networking. Therefore, yeah, when Kubernetes just decided to use Docker as container runtime, they just kept using Iptables for networking. The important thing here is though that Kubernetes does much more on networking side than pure Docker, right? Because Docker on its core, it handles containers. Yeah, Docker itself cares about specific containers, individual containers, right? While Kubernetes needs to take care about a lot of containers and on different nodes. So it needs to use iptables much more in order to provide the same network capabilities than raw Docker, right? For example, Docker itself won't let you connect to a container which is on different machine, right? While this is this is one of the points of Kubernetes. So yeah, I mean the point here is that Kubernetes was is still using iptables, and it's using iptables because Docker, when it was released, used iptables, and Docker used iptables when it was released because it just made sense at the beginning. So that's the history bit we need to understand in order to understand why are we talking about eBPF now. Maybe one thing to add here actually, yeah, kube proxy, the whole kube proxy component was built around iptables, right? Kube proxy itself is yeah, 90% of its job is to create iptables, manage iptables, just to provide networking for all the pods and all the nodes. Yeah, so yeah, if that would be a normal meetup, then I would now ask the audience who knows what it is. But since the line, then I'll just skip. This is the graph represents technical debt. Technical debt, yeah, I believe you all know what it is. Yeah, it's just the technology, or just the decisions, just the processes that were made in the past and has been never changed, even though that over time they become less and less effective, and at some point they started actually becoming an issue instead of yeah, they're not adding value anymore. They're just creating issues or some backlog tickets for you. And why I'm talking about technical debt? Precisely because actually I go back here. Precisely because iptables for Kubernetes is a technical debt. Yeah, let's put it that way. It's just what it is. At the beginning, maybe it made sense, but I would say not really. But I think it wasn't even considered at the beginning of Kubernetes because they just yeah, they just injected what Docker was using, right? So it was kind of natural to use iptables. But if you understand how iptable works, which I will explain in a second, then you will also understand that it is a technical debt for Kubernetes. So what it means is that, yeah, it's a technology which Kubernetes implements pretty heavily, like right, like I said, the whole kube proxy component, it's built all around iptables. So the point is, it's not easy to just not use iptables or use something else in Kubernetes because, yeah, Kubernetes relies on iptables very heavily. So I said that iptables is a technical debt for Kubernetes, but you may ask, yeah, but why actually? What's wrong with iptables, right? No, there's a lot of things wrong with iptables when we are talking about cloud native networking, when we are talking about containers, when we are talking about container orchestrators, when we are talking about IPs, which can change very quickly, like, right, every time we recreate a pod, every time we create a new pod, IP changes. And this happens quite often in Kubernetes cluster, right? But don't get me wrong, I'm not saying iptables itself is bad. iptables itself is pretty cool. I mean, it works just fine. It works perfectly. It worked fine for 20 years, and it still does when we are talking about physical machines and maybe virtual machines. For virtual machines, also still fine. The point here is that Iptables was created when there was no such thing as software-defined networking. Like the whole network was physical, basically. The whole network was just physical load balancers, physical routers, physical machines. So when Iptables was created, of course, it was created with physical networks in mind. And what it means. What it takes what it gives you that all the network is physical. The main point is that it doesn't change often, right? Of course, if you run a huge data center, then you may change load balancers. You wouldn't even change load balancer quite often. Maybe you add some machines once in a while, maybe you change faulty device, but in general, physical networks doesn't change often, right? Let's put it that way. And for that reason, one of the way how Iptables works, or let me put it all the way around, that how Iptables works was designed for this kind of environment where stuff doesn't change much. That's why changing anything in Iptables requires recreating every rule. All the rules in Iptables needs to be recreated if you want to make one single change, right? So imagine that you have 1,000 pods on your Kubernetes cluster, right? Every single time that you spin up a new pod or one pod gets recreated or you create Kubernetes service, anything that requires changing networking, which is quite a lot of possible operations Kubernetes, every single time something happens, you need to recreate every single Iptable rule in every node of your cluster. This is simply huge overhead for Kubernetes, and it's basically a lot of work for Kubernetes to keep all these Iptables rules updated. But yeah, we'll be talking about Iptables specifically in Kubernetes actually a bit later. So let me come back to Iptables itself. So yeah, first main point we need to understand is that Iptables are how to say it, static, very static, right? Once you save Iptables, in order to change anything, you need to recreate all the rules, right? It's like you print it on the paper, like, right? You print all the rules on the paper, and then when you need to make any changes, you just need to print it again, right? That's basically how Iptables works. And that's only about the pure Iptable rules, like simple Iptable rules. If you use something like Iptables chains, which I believe you do, like in any bigger network, or not even bigger network, pretty much anywhere you would find Iptables chains. You rarely can find Iptables usage when you don't use Iptables chains. So Iptables chains are linked list within Iptables, which means that one chain relates to the other chain, to the other list. And when that happens, when you use Iptable chains, this recreation of Iptables rules multiply, because I'm not sure if I'm able to explain this correctly fully, because it's also pretty funny thing. But whenever you use Iptables chains, you need to kind of do a loop operation over the chains and then over the Iptable. So it basically multiplies all this recreation. So yeah, that's the main first point, which is bad about Iptables. But again, it's bad when we are talking about Kubernetes. Another second thing, which is bad, is that Iptables is pure layer 3. Like, it doesn't understand layer 7. It doesn't understand protocols, doesn't understand speed, anything. It's purely based on IP address, protocol, port, nothing more than that, right? And again, it was perfectly fine for physical machines, for virtual machines. It was perfectly fine for its desired usage of Iptables. But again, when we bring Iptables to Kubernetes, to cloud native world, when the IP doesn't matter anymore in Kubernetes, right? We don't connect to pods based on IPs. At least you shouldn't. If you do, stop. IP address doesn't matter. What matters in microservices is REST endpoints, protocols, anything, just not IPs. which means that using iptables for anything in Kubernetes is is just not optimal. Let's say you're using a tool which was not designed to do what you want to do. That's why you need to do a lot of magic, a lot of workarounds in order to make that happen. Normally, for you as a Kubernetes user, you don't know any of that, so you don't even you are not even aware that this is bad, and because all of that is happening under the hood, Kubernetes does it for you. But again, it's extremely a lot of work for Kubernetes to do that, and that's why also we have tools which you need to install on Kubernetes to provide some functionality, because iptables works that way, right? So we need to create another abstraction on top of iptables in order to in order to bring some real security to Kubernetes. But we'll talk about that specifically also a bit later. Okay, so this is just an example from a great post that you should, that I linked at the bottom. I think I'll share the presentation afterwards, so you'll be able to access the link. There is a great post which explains exactly how iptables is used in Kubernetes. I'll just touch the topic on the ground because it's also pretty complicated. We wouldn't have time to explain you everything about iptables and eBPF. So I just want you to understand in general how iptables, how Kubernetes uses iptables to provide networking, right? We all know that every pod in Kubernetes gets its own IP, right? This IP, of course, is completely not related or different from the IP of your node. The IP of your node in Kubernetes is different than the load balancer on your Kubernetes, right? Then we also have at some point Kubernetes service, which also has its own IP. So what Kubernetes does with iptables is it just creates shitloads of iptables rules in order to make a logic out of that. If you want to have a connection, if your client, if a user connects from the internet and it needs to reach your pod, that's pretty much how it looks like in the simplest scenario. Let me be clear. That's the simplest usage of Kubernetes. If we would have anything like network policies or Calico or anything like that, you would see twice as much of these blocks. And each of these blocks is iptable rule. So again, when the traffic comes into the cluster, it needs to touch multiple iptable rules before it reaches your pod. And then again, every time that pod recreates, it gets new IP. All these iptable rules needs to recreate. You would think that, okay, if that IP changed, then I only need to update this iptable, right? Yes, you only need to update this iptable, but in order to update that iptable, you need to update or recreate all other iptable rules, because basically that's how iptables works. That's what I was explaining just before. So that's actually what I already said, that because of the way how Kubernetes uses iptables, or actually because of the way how iptables works, we need to do a lot of stuff, let's say, ourselves on top of that, right? So that's why we have separate tools for creating network policies. That's why we have separate tools like Calico to provide networking, because there are some limitations. So I mean, the point is that iptables are so limited in its core that we need a lot of stuff. Kubernetes needs to do a lot of stuff itself, and on top of that, you need to do a lot of stuff yourself, because there are these limitations of iptables. Okay. So that brings us to the main point of this talk, eBPF. Yeah, we can solve all of that with eBPF. Just let me point out again. Iptables. Again, I'm not saying iptables is bad. Iptables is bad when you use it with Kubernetes. Iptables itself is totally fine when we are talking about just connections between physical machines or physical networks. But again, in cloud native world, IP plus protocol doesn't tell you much anymore, right? In the past, like when we used physical machines, we could easily, maybe not easily, but it was relatively easy to understand what we are talking about just looking at the IP and port, right? If it was port 80, then okay, I know I'm talking about front-end application. If it's port 333, then I'm talking about MySQL. If it's port 3000, then okay, I'm talking to my backend. But in Kubernetes, pretty much if all your microservices are implemented as microservices, then they probably just expose REST API, right? So every microservice, no matter what it does, will be just exposing HTTP on port 80, no matter what it does. That's why, we need more than just IP and port management, let's say, in order to make proper cloud native networking. So, eBPF. Let me start with that. We will be talking about eBPF specifically for Kubernetes, but again, it's not eBPF. It's not something limited to Kubernetes. It's not something specific to Kubernetes. Okay, eBPF pretty much exactly the same way as Iptables is just the way is just Linux kernel functionality. Okay. So we're talking about eBPF in terms of Kubernetes, but in order to explain you eBPF, we need to understand the eBPF itself. Not related to Kubernetes. So I'll start with that just to give you understanding what this whole eBPF is, and then we will talk how this can be implemented in Kubernetes or how Kubernetes can use eBPF. So as I said, the main point to understand now is that eBPF is basically a technology in Linux kernel that can replace Iptables in Kubernetes for you, right? So we talked about all these disadvantages of using Iptables in Kubernetes, and basically, eBPF is the way to solve them. And main point why it can do that, there are a few reasons for that. We will be talking about that, but one of the main points is that it's layer 7 aware. Okay, so that's exactly what we need for cloud native environments, right? For microservices in Kubernetes. Because it's layer 7 aware, we can do stuff that normally we need separate tool for that to manage that. Okay, maybe that wasn't clear. So because eBPF is layer 7 aware, then we can do it natively. Something like pod A is allowed to access pod B because it has a role frontend, it has a label role frontend, and I allow pods with that label to talk to the pods which has labels role backend. I allow frontend to talk to backend, right? Something like this, which you can, of course, nowadays also do with Kubernetes, but to do that with Kubernetes now, you need you need a tool which you need to install yourself, and you need to do, and that tool will do a bunch of Iptable rules underneath in order to provide you that functionality. With eBPF, this can be done directly on the kernel level. This is huge advantage, especially huge performance advantage. But not only. We'll talk about that. Okay, but basically what you need to understand by now is that eBPF is something that can replace Iptables in Kubernetes in order to provide better networking, cloud native aware networking, and it understands layer 7. But as I said, eBPF it's not specific. It's not something specific for Kubernetes. It's just kernel functionality. So very quickly, I'll try to explain you what it is, but I won't go deep into details because we are focusing on Kubernetes. But you still need to understand what it is in general, right? So eBPF is a technology implemented in Linux kernel which allows you to write small programs which can do something. Simple as that. Simple as that. Basically, you instead of Iptables are pretty static, right? What Iptables is just a tool which uses netstat, which is another Linux kernel functionality. So netstat can manipulate networking in Linux kernel, right? And then netstat has its own logic. It can do something, but it's just a program which was written, which was implemented in Linux kernel, and that's it, right? You can't change it, of course, because yeah, it's just building into kernel. And then Iptables is just abstraction layer for netstat, which exposes to you some functionality of netstat, right? So whenever you do Iptables, whenever you add Iptable rules, then you have predefined set of rules which you can use. You can create your own as well, but that's you are still limited to what Iptables itself allows you to do. With eBPF, you are not limited because you are writing the program yourself. Yeah, that's pretty much what eBPF is. It's an interface for Linux kernel which allows you to write program which will touch directly to kernel. It can bind to kernel hooks, and based on events from the kernel, it can do something. That something is up to you because again, it's a program which you write. So there is this great comparison that eBPF is for Linux kernel like JavaScript for HTML. What it means is that if we talk about, go back again to Iptables, right? I said that it's pretty static, right? Once you create your Iptable rules, then they are applied. Then in order to change anything, you just need to reapply everything. You can't just change one of the rules. You just need to reapply the whole config. So that's pretty much like HTML works, right? Once you create a website with HTML, you can't do anything with it. You can just use it. Of course, you can implement like buttons and links and forms. So something will be changing on the website, but you won't be able to do anything else than was programmed. Anything else that was not defined in that HTML code, right? And then we have JavaScript, right? So what JavaScript did for HTML was to bring you exactly that functionality, that you can change something. So we can change something on the website based on events. So you can instruct JavaScript to listen, for example, when a user clicks on this button, execute that function. Okay, and that's pretty much how eBPF works for Linux kernel. It can also bind to Linux kernel hooks, and it can execute something, an execute function. It can execute something based on what's happening with the kernel. Okay, so yeah, that's pretty much. Oh, sorry. Okay, looks like. Let me quickly refresh because looks like I made changes to the presentation which weren't picked up. Okay, they were. Okay, fine. Never mind. Force alarm. So, so yeah, as I said, that's how that's basically how eBPF works in general, right? But now you may be thinking, now I updated it. Okay, sorry, now we are back on time. So you may be now thinking, what the hell are you talking about? Writing programs which touch kernel directly in order to do something? Yeah, that's pretty hardcore stuff, right? But that's eBPF technology itself. That's how eBPF technology itself works. But you don't need to do any of that. The same like you don't need to touch Iptables when you use Kubernetes, right? There is an abstraction for it, so don't worry. I just had to explain it to you how it works because first of all, it's pretty cool, right? It's really like JavaScript for Linux kernel. It's something really great. Yeah, which makes a lot of new stuff possible, and we'll be talking about that. So just to give you a quick understanding what it means to write a eBPF program, that's pretty much how it looks like here on the right. On the left, we have typical Iptables rules. Yeah, you just write a rule, you specify parameters, you specify IP addresses or ports or whatever. So that's how it looks to use Iptables, and that's how it looks to use eBPF. Yeah, but again, you don't need to do any of that because this can be abstracted. That slide shouldn't be here. I already talked about that. Yeah, so now we are coming finally to the point of how to use eBPF in Kubernetes. Okay, just a quick recap. We started with a little bit history just to understand, just to give you the understanding why Kubernetes uses Iptables and why it's not great for Kubernetes to use Iptables. Then I explained what's eBPF. And now let's talk about how we can actually use eBPF in Kubernetes and what it does to Kubernetes. So as I said just here, that you don't need to write any of these programs is because there is a tool called Serium, which basically provides an abstraction for you. So in order to use eBPF on Kubernetes, instead of writing all these crazy hardcore low-level programs which touch Linux kernel directly, you can just install Serium on your cluster and it will do all of that for you. As far as I know, Serium is the only one, I think, which provides that functionality for Kubernetes, which implements eBPF for Kubernetes. I may be wrong though, but I think that's the only one. And because eBPF gives you so much more possibilities than Iptables, right? Again, Iptables it just allows you to do whatever, yeah, only very limited amount of operations you can do with Iptables, right? Yeah, it's defined what you can do with Iptables in Iptables itself, so you can't do anything more than Iptable allows you to do. With eBPF, again, since you write your own programs, you can write anything pretty much. That's why the possibilities are limitless, I would say, right? And that's why Serium not only replaces Iptables for Kubernetes, it only gives you a lot of stuff, yeah, much more than that, basically. So the main point of Serium is to basically replace Iptables, right? So Kubernetes does not need to do anymore all this crazy recreation of Iptable rules every single time that something changes. It won't need to do that. Oh, looks like I skip another slide. Sorry about that. So it don't need to do that because Iptable eBPF works differently. Again, when Iptables implements hash table instead of list like Iptables, which means that, yeah, since Iptables is a list, then you need to recreate the whole list every time you want to change something. In eBPF, it's a table with just key values. So you can just replace specific key or like replace specific value for specific key instead of recreating the everything. That's why when, again, if you have 1,000 services in your Kubernetes cluster, you will have, yeah, more, but imagine you have 1,000 Iptable rules in your Kubernetes cluster. Then if you want to add a new Kubernetes service or a new Kubernetes pod or anything, you will have to create 1,001 Iptable rules. With eBPF, you just need to create one new rule because, again, it's a table, so you can just add a key value and that's it. The same when replacing, when something changes, you don't need to recreate anything. You can just find the specific key and just change its value. That's why it's so powerful and it's so, it gives so much more performance for a cluster because, yeah, Kubernetes doesn't need to do any more any of that crazy recreation stuff. But so far I talked about only about the providing networking and networking itself for the containers, right? But since eBPF doesn't limit you anyway, because yeah, you just write programs, then you can do anything pretty much with networking. You just hook to the Linux kernel, and you can do anything with whatever happening. That's why when you install Serium, when you start using Serium, it doesn't only replace you, it doesn't only replace iptables for you, but it gives you a lot of stuff as well out of the box. It gives you network policies out of the box, layer 7 aware. It gives you monitoring and tracing out of the box. It gives you a lot of stuff, because it's so easy for Serium to just write new small eBPF program and add new functionality. And the guys from Serium were really putting a lot of effort into implementing new features. As I mentioned at the very beginning, I started with looking into eBPF about a year ago, and looking at what happened, how it looked a year ago, and how it looks now. Yeah, it's just pretty impressive that there's so much new stuff that you can do, and it's really cool to see every new feature, because anything that happens in Serium happens natively directly on Linux kernel, which means that yeah, everything, yeah, it's just native, right? It's basically just native. That's it. So it's really cool to see, basically. Something off the topic a bit. You may have heard about a year ago, in August 2020, that Google announced that they implement new Google Kubernetes Engine data plane version 2. And what it was, basically, they implemented Serium. They implemented eBPF using Serium, basically. So I guess, yeah, if Google does that to their clusters, then it pretty much means that there is something about it, right? I didn't mention yet, but I hope you understand at this point already that eBPF is something something on the really on a low level, something that change Kubernetes on very low level, right? It's not like service mesh. It's not like Calico. It's not like all the tools that are popping up, because all of these tools like service mesh, Calico, they all use iptables under the hood. So these are just the tools which are built on top of iptables. While eBPF and Serium, it replaces iptables. Actually, I should mention here as well that it can replace iptables fully. It can Serium. You can install Serium in a 100% kube proxy replacement, but you don't need to. If you are using some very specific stuff, very specific tools, which are still requiring kube proxy on the cluster, then you could install Serium in a mode which doesn't fully replace kube proxy while still getting the all the benefits. So yeah, it's just something specific for you to decide if you actually want to look into Serium. So I've been talking about all this cool stuff about the eBPF and how iptables is bad for Kubernetes, but is it really, right? Give me some proof. So this is a simple graph showing the performance, how the performance decrease on your Kubernetes when using iptables. So when using normal Kubernetes, right? The more services you have in the cluster, the slower it gets, basically, right? Should be clear, right? If you have 5,000 iptables rules, if all the way around, if you have a small cluster, if you have 100 iptable rules and you need to add a new one, then you need to create 101 iptables rules, right? While if you have 3,000 iptable rules and you want to add a new one, then you need to create 3,001 iptable rules. So of course it will be slower. And yeah, it's just getting the more services you get, the more everything you get in the cluster, because services have IP, but pods also have IP addresses. So the more stuff you have in your cluster, the slower iptable will get. There is a way to help it slightly, like you can use IPVS now with iptables in Kubernetes. It helps a bit, but it doesn't change the fact that this is basically how it works, and you can't do much about it because that's basically how iptable works. You can't replace one. You just need to recreate all of them. So the dark blue is iptables and the light blue is Serium. You may be also wondering that I'm telling here how this iptables is bad, how it's slow, and so on, but you never actually, you think your Kubernetes cluster works fine, right? Well, yes, because at the end of the day, creating iptable rule, it's not really heavy operation, right? It's not like update to the database. It's super quick to create an iptable rules. So and of course nowadays machines have plenty of CPU. So even creating 500 iptable rules on 20 different nodes, it's still you won't see really that much. You won't wait seconds for it. Let's say let's put it that way. The problem becomes really on big scale, right? So if you are talking about like typical small clusters with 10 nodes, I don't know, 500 services, then you won't see that much of an issues. But if you are talking about clusters with 50 nodes and 5,000 services, then yeah, then our chart finishes at 2,700 services, right? So imagine if you would have 5,000 services, then that would be somewhere up the roof. So yeah, that's also one of the reasons. That's why you may not even notice ever that this is an issue for Kubernetes to handle all of these iptables. But yeah, basically, the more you grow, the more performance degradation you will see. Just to give you some example, this is taken from the real cluster from one of our clients cluster actually. This is the Kubernetes cluster which is running a big e-commerce shop. So I would say this is a like typical cluster for big company, not huge company, just typical big company. We have 38 nodes, 979 pods on that cluster, and 628 services on that cluster, right? And important thing to mention here actually is that this cluster uses Calico, and that's important because when you use Calico, then Calico itself creates shitloads of iptables rules in order to provide yeah, its functionality basically. So yeah, so these numbers or iptables rules are higher because we are using Calico, but then again, I think a lot of people use Calico, right? Oh, sorry. So yeah, with a cluster like that, 38 nodes, 600 services, almost 1,000 pods, we see between 1,500 and 2,500 iptable rules per node, which means we have 75,000 iptable rules in the whole cluster, which means that every single time that the new pod is spun up or anything changes, that Kubernetes cluster needs to create 75,000 iptables, because even if something happens on one node, you need to recreate iptables on the other node, right? Because yeah, that's basically how it works in Kubernetes. That's part of the job of kubeproxy actually, to route the traffic. If it lands on the node when the pod doesn't exist, the one you want to connect to, then it will just route the traffic to other pod, right? And in order to do that, it needs to keep updated a list of all the services and pods IP addresses on all the nodes. That's why, yeah, every single time you want to create a new pod or you delete the pod, you need to create 75,000 iptable rules in the whole cluster. Actually, not you, but your Kubernetes cluster. So yeah, as I said, Serium will solve that for you. How Serium works, it works like pretty much like any other tool that you would install in Kubernetes. It means that, yeah, you can just install Serium with Helm on your Kubernetes, and that's it in quotes, right? It's not like you need to do some, I don't know, hardcore, low-level Kubernetes custom stuff. You can just install Serium with Helm. You can also install Serium on managed Kubernetes cluster. That's not an issue. So yeah, how Serium works is basically, yeah, again, that you just install it with Helm. Then it creates a Serium agent on every node, which which acts for Kubernetes as a CNI adapter. And then it uses eBPF in Linux kernel to do its magic. So whenever a new pod needs to be created or something needs to be changed, instead of recreating iptables in order rules, Serium just update its key table, key value table. So yeah, it don't need to recreate everything. It just updates its own table. And that's pretty much how it works in a nutshell. And then on top of that, because again, I'm keep talking about the networking itself, right? About replacing iptables, but this is just tip of an iceberg when using Serium, because Serium can do, again, anything, right? Again, it's like JavaScript for Linux kernel. It can do anything which you will program it to do, right? Which the guys from Serium implementing new features. So yeah, stuff like network policy, load balancing, bandwidth management, policy logging even, and monitoring, all of that can be done natively through Serium directly on a kernel level. So you don't need all of the extra overhead for Kubernetes. You don't need install extra tools in order to provide all of this functionality. So I believe in typical Kubernetes cluster, in typical production Kubernetes cluster, you would install 2, 3, 5, maybe different tools in order to provide some of this functionality, right? One for network policy, maybe different for bandwidth management. But basically the point is you would just stack up on the Kubernetes in order to make use of iptables in a way to provide that functionality, which would mean that this number of iptables would grow even more, right? This is just a cluster with Calico and nothing else. If you start using more and more different Kubernetes tools to provide networking related features, then you would end up with much more of these API services, which means your Kubernetes cluster will become slower and slower. And actually, when I talk about Kubernetes becoming slower, I'm talking about updating networking stuff, right? It's not like the whole API will get slower. It will just it will just be slower to create a pod, because Kubernetes will wait for the networking to be ready. It will be slower to update, for example, the endpoint of the service when something changed. So something that we used to think that it's normal, right? Like if you have tons of microservices, tons of services, then people say, yeah, it's normal, of course, that sometimes it takes a while to update a service or update an endpoint or whatever. But it's not normal. It's normal. It seems normal because that's how it works. That's how iptable works, and Kubernetes can't do anything about it basically. But it doesn't need to be normal. You can just use Serium, eBPF instead. So also when you will start Googling, or just to basically say it again, just for you to understand, you may be you may be hearing eBPF from me, but you will be seeing BPF somewhere when you start Googling, and then we have Serium, right? So just to clarify, eBPF was the difference between eBPF, BPF, and Serium. Then eBPF versus Serium, I hope that's clear by now, right? It's like, eBPF is the technology and Serium is a tool, right? Serium is a tool which uses eBPF technology to provide you something. The same like Docker is a tool which uses C groups and namespaces in order to provide you easy containers. So that's the relation between eBPF and Serium, and BPF versus eBPF. eBPF, it's basically extended BPF, and it's basically updated version, or let's say version 2 of BPF. BPF, the first BPF is dating back to 1992, but only after the release of eBPF in 2014 it became actually quite useful. BPF itself, before eBPF, BPF was existing in Linux kernel, and pretty much only Linux kernel itself was using BPF for some stuff. While when eBPF was released, it became available to user as well to use kind of the same functionality, right? So yeah, it's just updated version of BPF. So yeah, so that's just to clarify this. And then yeah, I showed you a graph how performance degrades with Iptables over time. That's just another example how Serium helps in Kubernetes to do networking a bit more natively, bit more easier, bit more lightweight. You may have heard that when you install Istio, or when you install any service mesh, then you have that sidecar container within the pod, which hijacks all the traffic from your pod, right? I guess many of you heard how it works. But basically, what happens in reality is, yes, you have that sidecar container injected to your pod, but in order to get the traffic from that pod, the traffic needs to go from the container itself, from the service. It needs to go through the whole TCP/IP stack to hit the localhost interface. Then it needs to go through whole TCP/IP stack again in order to hit the envoy, and then it needs to hit the whole TCP/IP stack again in order to get out of the pod and be routed anywhere else. And then all of this happens again. With Serium, this redundancy is not necessary. The call can be routed directly through the sockets to the Iptables. Sorry, to the sidecar container, right? So that's just another example how Serium makes networking cloud native for Kubernetes, basically. This is just one example, but there's a lot of stuff that's happening under the hood when you use Serium, which makes it more sensible, more easier for Kubernetes, and more straightforward. Looks like I'm running a bit out of time, but I'm just almost finishing. So I told you how to start with Serium, right? So you can just install with Helm, and installs on the cluster like any other tool. And then in order to use Serium, actually, you basically use it also as any other tool on Kubernetes. You just define YAML files, and you just apply YAML files, and that's it. That's how you instruct Serium to do any of the stuff. The replacement of the Iptables, if you want to replace Iptables completely, the kube proxy, to replace kube proxy completely with eBPF, with Serium, then that's, you need to specify this as a parameter when installing Kubernetes cluster, and then you don't need to do anything. It will just replace Iptables for you under the hood. But then to provide all of this extra functionality I was talking about, like access control, like bandwidth monitoring, all of that can be just defined with YAMLs. So you could think of Serium in two ways. One, you could just use Serium just to replace Iptables, and that's it. So just install it and forget about it. And you are happy that your Kubernetes cluster won't get slower and slower over time when you have more services. Or you could actually start using Serium not only for replacing Iptables, but also to get all of that functionality. And then, then you would have to write all of these manifests. I mentioned also at the beginning that it's layer 7. Serium understands layer 7, eBPF understands layer 7, which means you can do stuff like allow this specific pod with I don't know, this label or this IP address or anything to access to do HTTP GET call on this specific endpoint to that specific pods or that group of pods. So you can do typical layer 7 HTTP stuff, but not only HTTP. You can also do you can also bring Kafka security to your cluster with Serium. You can just instruct Serium, hey, allow this pod to read from that topic, but don't produce anything from that topic. So it's not only HTTP. Yeah, it's basically layer 7, right? It's not we're not talking about HTTP itself. We're talking about whole layer 7. That's one of the examples about these extras which you get with Serium. That's screenshot from one of the Serium tools you can install on top. There's a tool called Hubble, which is also a Serium project, which is basically a UI, and it can show you stuff. So here we see an example that you can see the service map for your cluster just because you implement Serium and you use Serium. Monitoring, all of this you get out of the box when you install Serium. Of course, you still need to use Grafana and Prometheus to actually use these metrics because Serium will just produce metrics for you. But it will produce metrics for you out of the box. Okay, 2 minutes after, that's the end of my talk. I really hope that you get the idea, what's eBPF, how it works, how to start with Serium, what it does. I was about to run the demo as well, but I'm already after time. So if you like eBPF, if you are interested more now about Serium, feel free to ping me. Maybe we can organize separate meetup specifically for how to use Serium. And if there are questions, if we have still time for questions, then I'm happy to answer some questions.
David, thank you so much for giving the talk, for presenting the differences between old-fashioned AP tables and the new technology that's eBPF. I like very much. And there is actually one question, maybe not a question, but Kamil asked the question, would it be possible to compare what's the IPVS versus eBPF? Would it be possible in a few words? Just a
unfortunately not. I mean, I have zero knowledge about that.
Okay.
That's definitely something I wanted also to dive into that because, as I said, I just also started looking at Serium again just some time ago. So I don't know the details, unfortunately. Yeah.
Okay, sure. So we can cover that question later on, maybe offline. So
but just to add something, as I mentioned, IPVS definitely helps for Iptables, but it doesn't solve the problem.
Absolutely.
It's kind of I would say it's just a workaround. It's just covering the problem.
Okay.
So it still will be definitely beneficial to use Serium.
Have you installed on any production environment Serium already?
No. That's because Serium gives you the most advantages when you are talking already about huge clusters, right?
Okay.
As I said, on small clusters, on typical clusters, like I showed, the one with 38 nodes, if I would install it on that one, we would already see some benefits, but it wouldn't be like huge benefits.
Okay, cool. So definitely it's for large environments and for the large network traffic for.
I mean, that's when you would see directly the most impact, the most advantages. But definitely, if that would be my decision, I would definitely install it even on smaller clusters. Just because it already gives you the advantages. And also, so one thing is performance, right? One thing is that when using Serium, when using Iptables, you lose performance over time. But the other thing is that all of these extras like network policies, bandwidth monitoring, all of that can be done natively. So that's another advantage which you can already benefit from even on lower clusters.
Okay, so definitely there is advantages even installing Serium on smaller environments because you use the native built-in features into Linux kernel. You don't use Iptables. There are no lots of rules, and yeah, so that's very nice. Okay, do you know anything about how the Serium is? What is the license for Serium? Can we use it like a regular open source project?
Yep, it's fully open source.
Okay, cool.
Also,
Yeah.
that extra Hubble component, the UI, which is also pretty nice. Yeah.
Okay, so how to compare Serium to IPFS proxy mode? Okay, so I think we can cover it later on that question. So if you have any question, you can ask right now.
Yeah, I see there is also one comment from Pavel that pretty much everything about Iptables bet is actually about kubeproxy being incapable of diffing the rules it has created. Yes, that's definitely kubeproxy. Kubeproxy adds to the problem, but it doesn't change the fact that Iptables works how it works. You can't just change one.
You can.
You can't.
You can, because there is you modify rule by rule to the point that one of the bigger issues with Iptables in the past was the fact that you change it rule by rule instead of replacing everything.
You sure about that?
Yes, that's why NF tables were started.
Okay.
Actually.
Okay.
Essentially everything to make your presentation better, replace pretty much everything about Iptables with kubeproxy, and then it will be true. Because otherwise you might end up with a network engineer that starts to check the sources of Iptables and going, nope.
Okay, I'll check that. Thanks, but I was pretty sure that that's not the case. Of course, you can, if you open the file, you can of course change one rule, but when you apply that file,
the thing is, Iptables doesn't care about any file. There is just a tool which will essentially run iptables command with parameters from a file, but each entry is replaced separately, and that tool drops everything first and then readds. So it's not actually something that kubeproxy has to do, because it doesn't edit any file.
Mm-hmm.
It's essentially a deficiency in kubeproxy, which is not the only one deficiency there. Because, for example, tables like Serium uses are also part of Iptables. And in fact, annoyingly enough, a lot of clusters I have, Serium has to work through netfilter, which is the underlying infrastructure of Iptables, because I don't have specific network cards that enable Serium fastpath.
Okay, cool.
Because
So,
it's limited by hardware, which cards support XDP.
To make it clear, what kubeproxy does is actually just like shows out and execs Iptables save and Iptables restore, basically. Like back in the days,
yes, that's kind of a bug in kubeproxy.
But I was pretty sure, like back in the days, I remember like Iptables was like downloading the rule set, modifying and uploading the whole rule set. Has it changed like recently?
It
like,
never was like that.
Okay.
It's literally part of origin of NF tables, where they went like, we can't do atomic change in Iptables because you have an instruction to insert or remove a rule from the chain, but not a way to replace the whole chain in one go.
Great, thanks.
So sorry for a little misunderstanding then. I'll validate that and update that, but yeah, at the end, it doesn't change anything when we talk about Kubernetes.
It would open a more space to talk about XDP, which is a very interesting part of Serium.
Just admit, Pavel, that you wanted to, to tell you something more about it.
Something like that, because I worked a bit with this, and I would like to hear more about XDP when it comes to Serium, because that's a big change.
I guess we're
and
waiting
not enough.
for we are open for for a proposition of a new talk on this topic, because it's very hot. It looks like so. So yeah, that would be great. Yeah. So excellent. Yeah, great.
It's just more like feedback of improving the presentation for next time. I mean, I reuse presentations a lot before.
Okay. So anything else?
So seems we are good. Yeah, Pavel, thanks a lot for your remarks and your comments. It's very valuable. David, thanks a lot for the presentation. It's very nice. It was very nice to host you on our meetup. Hopefully next time we'll have another session from you. So yeah, it's still open and available for everyone who would like to give a talk about the interesting topics.
It looks
Thanks
like this topic is very hot, and maybe you have your own opinions on this topic. Maybe you want to share it with others, and we would be we would glad to host you. And so I guess that's it. So let's wrap it up. And Kuba, what do you say?
Thank you so much. Thank you for your time. Thank you, David, for preparing the presentation, and thank you all who attended to our to spend the evening with us. And yeah, that's all. So see you shortly. Stay healthy.
Yeah. Thank you, everybody.